And just to show you guys what I've done real quick, let me share my screen. And pull over our Moodle course real quick. So down here under week 7, I brought in some links to the information about each of the routing protocols that Packet Tracer offers. There are some other ones out there that are really, not used in the industry very much, so we're not really going to focus on those. But these are some others that are out there. Not others, but these are the 4 main ones that at least Cisco teaches. So I just thought I'd bring it to your attention that it's on Moodle if you want to take a look at it. They go into pretty good depth on each as far as how they do what they do. We're going to get into that a little bit. But before I want to do that, I want to play with Packet Tracer a little bit first and show you what I've done here. So I have created a new network called Toronto, and basically it's just a router. I haven't added any nodes to it. So in this business that we've got, Toronto is just like an office that has a piece of equipment in it that's plugged into network, and it doesn't have any computers in there or anything, any office equipment. It's just a box with power and network. So but what it does is it allows us to have this ring type network going. And move this over. I don't know if you guys can see that or not, but if you go to this computer, and we're going to do a simulation here. That's better. You go to this computer and you go to desktop, traffic generator. Yeah, we'll start a ping. We'll ping the DNS server there with our own source IP. And once a second, we'll just start that real quick. So we can see how the packets flow across this type of network. And it's using EIGRP, by the way, to share its routes between everything. So you've got a route going this way and a route going this way. And let's see what the packets will take as they go around. Let's try that. All right, did I click the wrong thing? I need to click ICMP is the protocol that ping uses. So that's what we'll check here to look for. And so now this should be running. Yeah, there we go. All right, let's try it again here. So it hits the that switch. I want to just let it go, but it doesn't want to go. Now I've locked it up. There we go. Let's do it this way. Okay, so it's sending a packet. We'll just do that. Let's see which way it goes. It goes that way to Toronto. Where did it go? Must have disappeared.
Are we going to be doing this in the lab as well, or is it just what's on paper?
If you want to follow along, you can, but I'm just showing you what the different routing protocols will do.
Yeah, it's not an extension of the lab. It's not.
Okay.
We're not adding anything else to your lab, no.
But if you notice, the packet, the return packet, actually went the opposite direction from what the original packet went. is what I was trying to show you guys. And so I thought that was interesting that it didn't take the same route going forward or back. And then if you do it again, it will see, now we've got a reply here. So then it will send another one, and it goes the opposite way. And then heads back from that server. And then it goes out to Toronto instead of Houston.
So is there any rhyme or reason it just goes whatever path it, I mean, it feels like any path it wants, or is it just
well, that's the whole thing is each of these protocols has a different way of deciding what packet goes where. And that's the whole routing protocol. So the EIGRP one actually has a very, very complex formula. You know, I actually got that article up. This is the formula it uses to decide what route to go to. And then these K numbers are constants that Cisco has decided. So yeah, they've come up with this big formula to decide which way to send your packets. And believe it or not, it actually works pretty well. So they're doing something right. The other way of doing things would be about OSPF, which is more based on bandwidth. Yeah. So basically, this one goes with different metrics that you've got set in it, and it goes by bandwidth. So if this path here has a higher bandwidth, it'll send more packets this way than it will use on the other side. So, and we can look at that. I was actually planning on setting up OSPF on these routers here just to show you what it would look like. But before I do that, let's see what happens when something goes wrong. And say, for example, this router gets turned off. Actually, let's turn it back on.
You just do it down on one of those interfaces?
Well, I was going to show you how quickly it comes back onto the network after you've turned it on. Assuming it comes back on. It seems to be hung. Try this back again here. Let's go back to real time. Maybe that's what the problem is. Yeah, there it goes. It was under simulation mode, so it didn't know what to do. So here it's booted. It's actually booted up now. So how long is it going to take before? Here we go. We got our neighbors up. Hey, I found you. Hey, I found you. So a couple seconds is all it took for it to converge back onto the network and be able to pass traffic back and forth. So whereas like BGP might take actually several minutes for it to figure out where it is in the network and how to transfer packets back and forth. But it also has to load the entire routing table for the entire internet on it. So that's the reason why it takes a while. But once it does, it will route and route and route without problems. So, whereas EIGRP is more like in a car analogy, EIGRP is like the Ferrari of routing protocols. It's very, very fast. Whereas BGP is more like a dump truck. So it can carry a lot, but it's very slow to converge, that is. So anyways, Yeah, let's drop an interface and see what happens as we're pinging. So let me get back onto here. I really want to have it both up at the same time. It doesn't want to do that. All right, let's do it this way. I could just grab it physically. So we can start our ping, and I can pull the network cable out. Come on, let it go. Things are not going well for me today.
You said the
Plug it in the wrong port. Nope, that doesn't work.
Did you want to remove that connection, or do you want to do it just like a shutdown on the interface?
Well, you know, it'd be nice if I could do a shutdown on the interface, but I'd also like to have this PC be able to be shown at the same time, and it doesn't want to. So, let me see. Maybe I can do it this way. Yeah, there we go. That's what I'm looking for. All right. So now we ping, go into the router here. We haven't set up a domain controller on the router, so it's trying to find this one character that I've got. It's going to take a few seconds for it to time out and say, nope, we can't find it. There it goes. Going to give me back control here. Status. See what we got. Really? Only do a show interface status, huh? Okay. Show run instead. All right, so let's just drop serial 0/1/0. Serial 0/1/0. So I'm going to type shutdown, and that's going to turn off that port when I do that. And let's see what happens when I do that. So it brought it down, and I can still ping. So in other words, the packets are taking the opposite route now that that port's shut down and I can't get anywhere. So it's taking the Houston network route over there. So if I do a no shut, brings the interface back up, and I can still ping. And now the neighbor has popped back up since I brought the interface up, and of course I can still ping as well. Whereas if, for example, we took this router and we turned it off, which would bring everything down, just to show you that, yeah, I cannot ping now from this computer over here because that router is off. So I've lost my redundancy because I only have one default gateway out to the internet. But everybody else can talk other than New York. Toronto can still talk. Houston can still talk. But New York is down.
So effectively, you can have a single link go down, like a wide area network circuit between Toronto and New York can go down, and you can still go through Portland or Houston over to Portland. But if the whole server or the whole the whole router goes down, like the thing completely fails or there's a power outage, obviously, then no traffic obviously can go through there. So if your router fails, then you're out of luck. But if only one link goes down, you still have got another route the other way, whether it's through Toronto or through Houston. You can get to Portland either way there. And so you've got redundant routes, and you can have a failure, a single link failure, and still keep talking. But there is a moment when these links go down that there has to be some convergence where they all share their routes and go, hey, that link between Toronto and New York is down now. And so they update themselves within this autonomous system to update, say, hey, there's no link between Toronto and New York. And therefore, if you want to get to New York from Portland, you got to go through Houston only now.
All right, so that kind of shows you how the redundancy will work to where, you know, if you have more than one route, you're able to communicate. And that's kind of the whole idea about the internet in general. They have routers all over the world that so your packet may go from here if you're say communicating to a web server over in New York, your packet may go through Poughkeepsie and Arizona, and you can go through Texas and on up to Ohio over to New York, or it might go from here to Montana to Minnesota or something like that over to as well. So you know, there's all kinds of different routes it could possibly take in order to get to your destination. So let's jump into this router here. If you notice, well, I've kind of labeled some things on here, but I wanted to show you here this particular router. In fact, well, also Houston too will be a good example, but this particular router, it's got 2 serial connections, and if you look in the CLI, you're not sure which one is which other than the IP address that you've got put into it and the helper address for the DHCP server. But just the configurations itself, you're not sure which one goes where. Is this going to New York or is it going over to Portland? So what you can do inside here is you can do a config T, interface, serial 0/1/0. Now this is my 10.1.1.10, which is going to New York, it looks like. So what I can do is I can type on that interface and do a description. Oops, I gotta type in the actual description. So description, and then you type in whatever you want to label something. And whenever I label something inside the configuration of the device, I always use capital letters, because if you notice, everything is in lowercase, so it really stands out if you put it in caps. So for this one, I would do to New York, like so. So now, get back into just the command, do a show run. Now you can see it says to New York. So you can kind of label your stuff. The other thing you can do in addition to that is you can make an actual name for your router instead of just router. That way, if you're doing a real network where you're not in packet tracer, you can just click and point and click on it. But if you're doing a real network, you can get confused as to where you're at in your network if everything's labeled the same. So in this case, we're on the Toronto router. So we're going to do host name Toronto RTR. And so now my prompt has changed to Toronto router. And now it shows you, even when you get into just the basic CLI part, I've completely gotten out of everything. It says Toronto router. So you know where you're at in the network part. So you know which device you're connected to and which device you're configuring. So helpful information. Okay, so right now, like I said before, we're running EIGRP, and I just wanted to show you what the difference is from running, say, OSPF, which is similar, but it's a little more on the setup side. OSPF, you're required to have an area. You're also required to use, like, router EIGRP 100 here. 100 is our area. So EIGRP has a similar setup as far as areas go, but OSPF has an additional setup for it. I'll show you. So when you go in here, you go to config T, and you have to go no router EIGRP 100, and now it's not talking on EIGRP anymore, and in fact it's lost all of its routes. So you do, to get down to OSPF, you do router OSPF, and then you pick a process number. I usually just pick one, but there's a variety of numbers you could pick if you wanted. 1 to 65,535 to be exact. So I just press 1 for the first process. And then you can do, then this is where you start advertising your networks, just like you do with EIGRP. You do network, and then 10.0.0.0, oops, yeah, 10.0.0.0. Now here, they want a wildcard mask, wildcard bits. So if you remember an earlier conversation, wildcard mask is similar to a subnet mask, but it's opposite. So in this case, like a subnet mask would be 255.255.255.0. In our case, it would be 0.0.0.0.255. Actually, what we really want to do is we want to do 255.255.255. And then this is where you got to put in the area. So I press the question mark, and it says you have to do area, and then you do 0 is the first one, area 0. And then for that router, that's all we need to do, because the 10.0.0.0 network is on both legs, so it will automatically figure things out. So that's our configuration there. Right to mem. Then we get on to New York router. And if you notice here, its neighbor here, hold time expired. In other words, I haven't heard from the Toronto network talking on EIGRP. Well, that's because we're using OSPF instead. And so it doesn't know what to do. So let's configure it. So you do no EIGRP 100, and you do router OSPF 1, and then you do network 10.0.0.0, and the wildcard 0.255.255.255, because it says a class A wildcard, area 0. And then also, because of our LAN here, 192.168.250, we want to advertise that. So we want to do network 192.168.250.0 and then 0.0.0.255 area 0. Does that make sense?
One
'Cause
thing
we
is
are in the same area.
Yeah, one
Somebody
thing
say
that's
something.
different with this is you've got both. You've got your autonomous system. In this case, 1 instead of 100. It's your group of routers that are in the same grouping. But then you got
Yeah.
this area 0.
Right. So the area is the same thing as the autonomous system. The 1 is just a process on the router. So it's got to run an actual process. So this is just a number for the process that it runs, like a thread on the actual processor for the router. So it's just a number. You can pick 1 to 665,000, and so that way you can run multiple instances of OSPF if you want to. But that's way beyond what we're going to do in this class. So anyway, so if you notice, before I started typing the 192s, we ended up with an adjacency change with OSPF. We have a neighbor here, NBR, and it went from loading to full. So it's a full neighbor, and it's all done. So we've got a neighbor out to Toronto, in other words. And then we're advertising 192.168.250. So we're done on this router for right now.
You want to do a show run? Just show them how it looks like on the interface there.
Show run. So now, let me get down to the routing part of the configuration. It says router OSPF1, which is the process ID. And then we got network 10.0.0.0.255.255.255 area 0, and network 192.168.250.0.0.0.255 area 0. And that's the wildcard mask for a /24 network. And this is the wildcard mask for a /8 network, if that makes any sense, which I hope it does, because we've been talking about that. All right, so let's move on to the Houston. We'll do the same thing here. Notice it says, hey, I don't know if I lost a neighbor. Of course you did, because we're not on the EIGRP anymore. So no router EIGRP 100, and we do OSPF. Oops, I got to do router first. Router OSPF, and we'll pick 2 this time because it's a process ID on the actual router. So just for grins, we'll do 2 instead, and then we'll do network 10.0.0.0 and then 0.255.255.255. Right, just 255, and then area 0. That's the important one. Got to have that as area 0. Otherwise, the other routers won't talk to that if you have it in a different area. And we just see that we've got a neighbor over here on 192.168.250.1. So that has brought itself up. We also want to advertise our own network of 192.168.200.0. And then, of course, 0.0.0.255 is our wildcard mask for that. And then area 0. That. Now, if you want to see on the router what it knows about, you can do a show. I think it's a show IP route. Yep. And it will actually do it will show you what it knows about. So it knows about 10.1.1.0, 10.1.1.4, 10.1.1.8, 10.1.1.12, 192.168.200s, 192.168.250.
Look at the, yeah, you're seeing what the C's and the O's
This,
are. Yeah.
these identifiers here, when it says C, that means it's directly connected to this router. And then O means it's being learned through OSPF. If it was an E, it'd been learned through EIGRP. So it knows where to go based on this table that it builds. So finally, our last router, T. Before I do this, let me just show you what it looks like. Show IP route. And of course, it doesn't know about much because it's we've stopped doing EIGRP, and it's only talking at EIGRP. So everybody else is talking OSPF, and it's only doing EIGRP. So what you can see here is the connected routes that it knows about, but then it also knows about the 10.0.0.8 network through EIGRP. So this code here kind of shows you what each of these codes here means. So D, I'm not sure why it's not E, but for D, it's EIGRP. So, and then apparently you can do EIGRP external with EX as well. So, but we're not playing with that right now. So, anyways, so let's go into configuration mode and do no router EIGRP 100. Do router OSPF. Do 3 this time, and then do network 10.0.0.0, and then 0.255.255.255 area 0, and then another one for the local. Oh, there we go. We got 2 neighbors, and we found another one. So we have 2 neighbors that it showed up. In fact, before I get going here with the last network, let's do a show IP route and see what it knows. So it knows about, it's directly connected to 10.1.1.0. OSPF brought in this one. It's directly connected to 10.1.1.8. OSPF brought in 10.1.1.12, which is over here on the Toronto side. It brought in, it knows about 192.168 directly connected. And then it also knows about the other 2 networks that we've got going over in Portland, or Portland and New York. But let's advertise the last one here. So you do router OSPF to get back into. Oh, you got to type in the process ID, and then you type in network 192.168.200.0, and then 0.255.255. Whoops, I forgot the wrong one. 0.0.0.255. And then of course area 0. So we're all in the same area. And now everybody knows, should know, everybody goes.
Hey, but you're on Portland though, right?
Yeah, that's Portland router.
That's
I was just on.
net. Did you wanna
Oh, you're right. You're right. Misconfiguration. So now everybody can't talk. Good catch. So now to fix that, this is a good showing. So if you do a show run, go down here. So you can see that I've got this misconfigured. It should be a 100, not a 200. And so what you do is you go back into configuration mode. You type in OSPF, router first, sorry. OSPF 3, because I use the 3 for the process ID, and then you do no network 192.168.200.0.
You got a typo.
Now I'm going to try.
You got a typo right there.
Yep, I'm going to
Network.
try to just use this command. Nope, it says incomplete. So I got to keep typing. 0.0.0.255. Nope, incomplete. Keep typing. Area 0.
And why he's doing that is
There you go.
sometimes you start typing a command on a Cisco router and it says, well, I know there's only one that starts off 192.168.200, so I'll just remove that. You don't have to put the rest of the line, but apparently you had to put the whole line in there.
Yep. Oh, and now I exited out, so I got to type in router OSPF 3, and then I can type in the proper network 192.168.100.0, and then 0.0.0.255 area 0. Now I'm advertising that set of routes to everybody else, so everybody else should know about me. So now I should be able to go to web browser and www.stmartin.edu, and there we go. We brought up our web page. So we're able to communicate. I know I went through that kind of quick. Does anybody have any questions about it?
Kind of an odd question, maybe. Obviously, inside the command line interface, learning those commands and being aware of your environment settings, is there any command you can do to kind of a one-stop echo or something that'll show you the condition other than just showing the configuration? And is there a way to maybe dump that to a file, or is it all self-contained within the command shell?
Well, the configuration itself you can pull off. It's actually just a file on the router, and so you can pull it off using a variety of methods. Packet Tracer doesn't have a lot of the commands that you can have on a real Cisco router or switch, but I've used USB drives as well as TFTP to transfer files back and forth from routers. That's typically how you do it. Curious what they do have on these.
And you can have a repository of these configuration files, like on a server, as a backup for all your configs. So these startup configs that you have, like on these 4 routers now.
Yeah.
If the only place you had it on the router was the router, and the router, like the memory failed or something, you wouldn't have a backup. So with Cisco, they've got the ability to actually save that to a configuration server, and in their GUI configuration, you could take that and load it. You know, obviously you have to name it, you know, like Portland router or something, 1841 or whatever, something to distinguish it from the others. But you can name it and then dump it on there as startup config or something, right?
Yep. So if you use the dir command, it will show you the contents of the flash memory it's got. Although I don't see the configuration file, so it might be one of these default XMLs, but normally it's a config.text is the config file for the routers.
Okay.
But because this is Packet Tracer, it does things a little bit differently, it looks like. So
that leads me to another just quick overview. You mentioned early on, obviously, and very well pointed out that with the OSPF and the EIGRP, that, you know, those are like processes, so that the enumeration starting at 1 was very clear. And then you use the area at 0. And to me, I'm trying to figure out and get a grasp on all these logical areas. You also early on mentioned domain controller. Obviously, if we're talking about apples and oranges, establishing a domain controller or any of that, would that affect any of the things that you just did in terms of working working your way through to determine a pathway?
domain controller is going to work at layer 7 for the most part. It's more of an application type networking part of things. Where I'm working at here is layer 3 and 4. So yes,
Okay.
it's a much lower part of things.
And I see it more of like where you're looking at direct connections and relationships, whereas, you know, with the domain controller, I may have gotten a little confused, but I'm thinking that it's more of a logical description of who, you know, who's in control of certain functions about the network, but not a connect like you're doing with this. You are
Right.
directly connecting and establishing communication protocols between those devices. So
Yes. Yep, you got it. So if you do a show proc, it'll show you all different processes that are running. On here should be OSPF somewhere, if it's a real router. Protocols might be one of them. Yeah, I don't see it. But IGMP I recognize, that's a ping protocol. So you can ping from your router other places. So if you wanted to ping 192.168.200.2, you can. For some reason it's not pinging though. That's weird. Oh, because it's 200. I typed in the wrong thing. Should be 100.2, not 200. I got 2 on the brain. There we go. So the exclamation points means it was successful. A dot means it is not successful. So you can actually ping from the routers to each other or to individual devices as well. And ping runs at, like I said, layer 3 or layer 4, depending on how you want to look at it. It's a TCP/IP stack. So that's where ICMP runs on top of. So. Any other questions?
So one thing to remember, Peter removed EIGRP, Enhanced Internet Gateway Routing Protocol, and added OSPF. And the area, still the same thing. It's a region. They share routes between one another, so they can create a route, and they can go now through Toronto or Houston to get between Portland and New York. So 2 different routes, but these are 2 different dynamic routing protocols with 2 different areas of memory. So effectively, he could have ran both of these. He could have ran both EIGRP and OSPF at the same time as 2 dynamic routing protocols.
Yep, and in fact, you can run OSPF on one interface and EIGRP on another interface, and advertise routes that way to make it a kind of a border device between areas.
Yeah, let's say that these routers, they also had their own connections to the internet. So right now they're just connected with an intranet. It's just a LAN, WAN. So of a company, they're all connected together, but it doesn't go to the internet at this point. But if New York, Toronto, Houston, and Portland, they each had their own internet connection that came into this switch or this router, then you would need to communicate BGP to the internet, because that's the dynamic routing protocol on the internet, whereas you would want to maintain EIGRP or OSPF with your internal WAN and LAN routes with your intranet, so that your communication in your company would dynamically route based on that.
Peter, you were showing the formulations that Cisco did, and I understand from their point of view that they've done a lot of research and they've spent money. So those constants, those K quantities, obviously, are something that they've determined. But is there any connection between that formulation and which protocol? Like in this instance, where you're, like Mark was just suggesting, that you may have 1, 2, or 3 types of protocols in place to accommodate, you know, different types of traffic. Is there anything in your experience that would suggest that it's going to prioritize a protocol?
Not in my experience, but
Okay.
I'm not that experienced with running multiple protocols at once. Usually use one or the other. You don't like mix the 2 unless you've got a massive network you have to manage.
But, well, that actually answers the question. Obviously, then a good net engineer is going to say, look, let's just stick to one that works really well. And
right.
So, okay.
So the reason why you'd want to pick one or the other, EIGRP is proprietary to Cisco. So if you're only running Cisco devices, then EIGRP is the choice, because it is just a beast of a routing protocol. It's very, very fast. Whereas OSPF is industry standard. So if you're running some other manufacturer's device, such as Juniper routers, or even like a Palo Alto firewall can do OSPF routing protocols. So like I said, it's industry standard. So if you've got a mix of devices on your network, which most places do, then you're going to try to run OSPF instead, just because you're not able to run EIGRP because it's proprietary to Cisco only. And there's a few things that Cisco does that are proprietary to Cisco only, that are similar to this, but this is the routing protocol part. On the switch side of things, they have a protocol they run that communicates between switches, that tells them where they're at on the network. And it's called CDP, Cisco Discovery Protocol. So they can discover each other and tell them, hey, I got a switch over on my port over here. Oh, I've got a switch over here on my port. It runs at layer 2 rather than layer 3. But there's an industry standard protocol that's similar to it, but it's not CDP. It's called LLDP, Link Library Data Protocol, or something like that. So
you were going to say Spanning Tree Protocol, STP.
Actually, Spanning Tree, I think it was invented by Cisco, but they've made it industry standard now. So everybody talks Spanning Tree the same way now. They have different varieties of Spanning Tree, and we should probably talk about that at some point in our discussions.
Yeah, as an element of switching, and that also is something that in this case you can have multiple routes with routing on layer 3 here from Toronto, New York can go to Toronto, or Houston to Portland. But with switches, they typically have one link. I mean, you can link multiple ports together to make an aggregated link called link aggregation. But if you don't do that, if you have 3 switches and they all connect to each other, you can get what's called a bridging loop, and packets, the broadcast packets, can get in there and can't get out. They just keep looping.
Right. So if I were to create, say, another switch here, and do something heinous, like connect them all together. Now, obviously, you can't really do this in real life because we're on the other side of the country, but for demonstration purposes, if you were to do this in real life with 3 separate switches, you will bring down an entire network doing this, because none of these switches can now talk, and they will flood the local network here with broadcast packets.
Yeah. So what happens is, let's say PC3 on Houston, it sends out a broadcast for a DHCP address, or maybe to update the lease on the DHCP address. It sends it to that first switch, then that broadcasts it out to every port except the one it came in on, which goes over to the other switch in New York, and also the other switch 0 that he put in there. Those 2 then take that and pass it out every port except the one it came in on, and all of a sudden, this traffic just gets caught in this endless loop. This broadcast keeps getting broadcast, and this triangle, that the packet never ends. It just keeps getting, these broadcasts get passed around. PC2, maybe it does a DHCP broadcast or ARP broadcast, or PC4. And all these broadcasts just get caught in this triangle and never end. And so all the bandwidth at one point can be totally consumed by just broadcast traffic. They just keep looping around this. It's called a bridging loop. Never can get out of that loop until you disconnect one of these connections between these switches. And that's what Spanning Tree does. It says, okay, I'm connected to you and you're connected to him, and wait, he's connected back to me. So what it does, it says, okay, one of these connections, I'm going to disconnect automatically. Okay, and you see right there, actually, that switch 0, that has not come up. That orange dot says that is not forwarding traffic right now.
Right.
So
And
it's
that's
disconnected itself. So there's not a bridging loop, and there must be an automatic command for that on the switch if you look at the config, but it's saying, I'm not going to connect between switch 0 and the New York switch, because if I do, then we have a bridging loop. And
yeah, that's because by default, all Cisco switches have spanning tree enabled on them, some form of spanning tree. So that if you were to plug in a situation like this, it would not bring down your entire network if you did that. However, in reality, there's a lot of other devices that are out there that don't run spanning tree, and you can still bring down an entire network that way. So that's one of the reasons why you want to set up VLANs on your network, because that will segment your network further, so that if you do end up with a bridging loop or a broadcast storm, it's the same thing. It won't bring down your entire network. It'll only bring down a part of your network.
And I've actually seen this happen, and I've had to troubleshoot, and I walked into a closet and somebody had some kind of hub or something on their desktop, and they plugged it in to one port and then they plugged it into another port. And it basically made a link between several switches. So there was a loop like this, and then it caused this bridging loop. And I walked into the comms, and green, blinky is good. Orange is warning or problem. Sometimes it's a different, 10 or 100 megabit configuration. Then red is bad. Well, a solid green means there's so much traffic that it's just a solid green. It's just tons of traffic. Just a blinking green means traffic is passing on that link. And so just by disconnecting that manually, just pulling the connection off, broke that link and stopped all that broadcast traffic, and everybody started talking again.
Yep.
Mark, is it actually possible to create a virtual triangle, or is this only a thing that you'd worry about specifically with the physical connections?
Virtually?
Yeah. I mean, if you assign obviously a function that says we need more bandwidth space, but we can allocate, some part of the machine network, but we're using the same machine. I don't even know if that's even a possible thing. So I hope it's not a non-relevant question, but the idea that you can create a loop seems to me that if you have something even virtually that acts as maybe a kind of rerouter or some kind of thing that you've established to do additional routing, is it possible that you could do that? And I don't even know if it's possible.
Yeah. No, these switches, they run at layer 2. And so, yeah, you're talking physical connections between them.
Okay.
We had a situation about a year ago where one of our technicians, who will remain nameless, it wasn't me, took one of our IP phones and plugged in one side to the wall, and it's got 2 network jacks on it, and you're supposed to plug in the other to a computer. Well, he plugged in the other side of the wall, and that bypassed the spanning tree protocol on that switch, and it brought down our network. So,
Okay.
yeah, we yelled at him for a little bit once we traced it down.
If you do a show config or show run, you did show spanning tree.
I did a show spanning tree here.
Yeah.
And that shows you that spanning tree is enabled, and that the root ID is this switch here, and that we have it a link on 21, port 21, that's the root, and then we have another link on 19, and it is blocked. BLK means blocked.
It's forwarding traffic on 19.
Yeah.
Forwarding on 19, but blocking on the other, right?
Right. You got it. So if I were to say, go to this one, yeah, we'll just CLI, go to port what was it, 22? You notice I'm on the switch and it's got kind of the same look and feel as the other ones do. So the Cisco iOS is kind of universal between all of its devices. But
Yeah,
if we
switches and routers and
0/22, if we do a shut there, that, oops, that's the wrong one. I want to no shut that. I wanted to shut the other one. And then, so the other one's 23. Yeah, that's the one I wanted to shut down. So if you notice, if I were to shut down this link here, this one should come up in a minute.
yeah, so
Once
you
the
shut
spanning
down
tree
one that was
protocol has looked
active,
at it.
and now spanning tree's like, wait, this little link between these switches between Houston and New York went down. It's red, and you see the arrows down. It's administratively shut down. So that orange between switch 0 and New York should come up and be.
Yeah. It might take a minute for it to reconverge. Spanning tree is not very fast. So it's got a hello time of 2 seconds, aging time of 20 seconds.
There it goes.
So we're talking, yeah, lots of seconds before it finally figures itself out. But
There's a port fast command for spanning tree for ports within a switch to so it doesn't go down. Like if you had a IP phone, like a Cisco voice over IP phone, and the phone was going on and going off or something, it would keep causing this because every port would be part of the spanning tree a group. And so you can take all those just regular ports out of spanning tree and they just start forwarding traffic immediately. And then just have the major uplink ports that connect the switches together. Those are the main ones that have spanning tree on. Those are the ones you want to have look at if one of those goes down to converge and resend, not routes in this case, but just connections at layer 2. So it's kind of like routing with convergence, but it's at layer 2.
right. So if you notice, I brought that link back up and it had these two down for a few minutes while it, or a few seconds while it figured itself out again. And then this switch said, uh-oh, we got a loop going on again. Let's chop this one off. So it killed this connection. So yeah, that's how spanning tree works. It's interesting. It's fun. There are different flavors of it depending on how fast you want to get the convergence and the linking to take place. Standard spanning tree, it might take a couple minutes for it to finally figure everything out and come on up. If that's too slow for you, then you use what they call a rapid spanning tree instead. I'm not sure if that's available on these switches or not. And then there's another variety that Cisco uses. The latest one is rapid spanning tree per VLAN. So you can do different spanning tree setups depending on what VLAN you're on.
You can do a show run on this switch, and I think it'll show that the spanning tree is turned on, right?
Yeah. So this one is PVST, per VLAN spanning tree. And so if you wanted to, you could do a config T and then do a spanning tree and a question mark. And you can do port fast, VLAN, mode. There we go. Mode, that's what I'm looking for. Mode, and then a question mark. So you got PVST or rapid PVST. So we could turn on PVST and it would do the same thing except faster. It would come up within a few seconds rather than half a minute or so. So yeah, that's kind of some of the switching technology that we've got in these devices.
I would like to ask to make clear, obviously, that with the spanning tree technologies, its sole purpose in life is to prevent looping that would interfere with packet transfer I'm not, linearity is not the right word, but packet transfer, performance. Would it be wrong of me to look at it also in a way like when you say a spanning tree, I was thinking, okay, the root ID would have been the origin point, and then of course it would fan out and like the old, what was like, what was it, upstream, downstream? I used to hear that a lot. But so the SCP, its only purpose is to detect a possible loop issue and then prevent that. Is that the way I should look at that, and not try to imagine it as some kind of protocol tree, so to speak?
Okay, so the way I think about it is it's got two functions. One is to detect a loop on the network, and then two, to decide where to chop the tree down to chop the link, to stop the loop. So that's the way I think about it. Obviously, it uses a tree structure within itself in the programming part of it to decide who gets what link to chop down, to cut.
Now that works. Like me thinking about a mutated branch that grows back into itself. That would make sense. So that's good.
Yeah. Any other questions? Pretty well exhausted our
I got a quick question.
routing. Yeah, what's up, Gary?
So is that so the way that the packet is sending up and down, is it something related to the load balancer? That's really similar how they calculate where to send?
Similar. The load balancer, I want to say that runs up at layer 7 or so. That's a server technology that figures out which web server you want is going to do the processing to access your web page for.
Yeah.
Which mean that can the priority or the property of sending the packets can be modified, or is that just like stick with the EIGRP, or depends on the adapter that you're using or module?
Well, like I said, EIGRP and OSPF are a layer 3 protocol, so it runs much lower than, say, the load balancer on a web server does. Load balancer just balances between the actual servers, so you can have multiple servers serving web pages to multiple people, so it doesn't get overloaded.
Oh, so it can't be modified, like per se that I wanted to send it to this router as priority, and then send that as like backup, or some, like I want to use the Houston network. Let's say I'm in the New York network trying to communicate with the Portland one. I want to use the Houston as priority, and then if it's down, use the Toronto on backup or supplement. Can you set those things on the router, or is that something that you can't manage with?
That would be set at the web server, so that, like I said, you're talking apples and oranges here. The routing protocols on the actual routers themselves, that's just for them to communicate with each other, and that just decides which packet goes where across the country. Now you can steer it. There are ways of adjusting the different metrics on each of the protocols, so you can steer the traffic through various links. Like if you have a link that's really high speed, and for some reason the routing protocol isn't sending it enough of the traffic across that high speed link by default, then you can tweak the metrics so that the traffic flows through the higher speed, less congested links. So
Okay,
does that make
thank you.
sense?
Yeah.
Yeah, maybe, yeah, there is a way to modify it. Let's say you've got a bigger pipe between New York and Houston, and then Houston to Portland, but all your traffic between those 3 sites goes across that. So maybe the algorithm chooses to send traffic through Toronto to Portland, but you'd rather not go that route because it was a lower bandwidth, and maybe your WAN circuit was, you paid by the amount of traffic that's sent over it, and you got a better rate for your circuit. So they were actually looking at how much data went over that versus you had unlimited data from New York to Houston and Houston to Portland. So that's the route you want to send everything over. So to reduce your costs, you're right. You say, hey, even if maybe Houston, New York to Houston is a little more congested, send it over that
Right.
as a default unless it's down, something like that, right?
Right. And with OSPF, it has a metric called cost. And so you can adjust the cost for the router going to this network here to be higher. You have to go in and manually set it up. That's where the network engineering part of things comes in. So it's a little bit more than this course is supposed to go into. But yeah, you modify the cost aspect of the OSPF algorithm going out this link here. Whereas, or you could lower the cost on this link here. If I get into the CLI, I might be able to show you. I think. Really?
Doing oh, show up your route.
Yeah. This might show it. Yeah. And Packet Tracer might not even have the all of the commands for OSPF or EIGRP. EIGRP, you can modify any of those K values that we saw and adjust it that way as well, and really tune things to the nth degree. Although Cisco recommends you don't do that, that it works great by itself. So, which I have to agree. I have not had bad luck with it. Let's put it that way. Just really configs the MR. So. And that just shows the OSPF ones. Maybe that's it. OSPF there. IP OSPF. There we go. So they have these LSAs, which are link state algorithms, and they're little packets, they're little hello packets, and you can control how often you send a hello packet out. This SPF algorithm is the shortest path first, is what that stands for. That's what the algorithm is that actually decides which path to take. And then that's the one that it uses to decide, you know, hey, I've got Toronto over here and I've got Houston over here. You know, we're going to send a packet out this way and we're going to send a packet out this way. But that's the only thing that we've got here. You got number of areas and then hold time. So again, it's a bit more than what this class was supposed to be, but you could do router OSPF one, I think, on this switch. Yeah, so you can do auto cost, you can change the bandwidth, you can do the distance, different modes. You can specify a neighbor, do it like a manually neighbor. You can also do passive interfaces or redistributed routes as well. Again, all of that is kind of beyond what we're going to go into here in this class, but there are many parameters you can go through and tweak in order to adjust which route you want to take depending on the specifications. Normally, it's going to take the highest bandwidth route, but if like he was saying, like Mark was saying, if your highest bandwidth route costs more physically, like you cost the company more, then maybe send more traffic out your slower link than the high bandwidth one. Or maybe you want to save the high bandwidth one for the really important traffic, and that's not really on your own network. That may be some other network that the high priority stuff is. So the low priority stuff you want to send out the other route. There might be a variety of reasons why you'd want to tweak it.
Well, I don't want to interpose two massively different subjects, but in telecommunications, least cost routing, just like the auto cost stuff, was done when customers would say, hey, I just want to make a phone call from here to there. But in the network itself, AT&T or whoever may have leased those lines to other sub companies. And even though it might have been shorter, it might have cost them more to use that. And so there were some specifications set up, obviously, between the switches to determine how to do that without, the auto cost was done at that level as well. So I see why the features there, although I agree with you, it's a big can of worms because it can change across a number of variables. So.
Yep. You got it. And then you thought OSPF had a lot of different options to choose from. Look, BGP has a ton. In fact, in order to get your CCIE, which is the highest certification you can get with Cisco, that's where you start becoming an expert at BGP. Before that, it's just a protocol. You don't even have to worry about it. When you're talking like the CCNA or the CCNP, it's just I think in the NP, they require you to set it up once, just so with the basic default values. But the CCIE level, they want you to be an expert on BGP, which has just a ton of different levels you can get to it. And for those of you, if you're interested in getting a CCIE, that's, from what I understand, that is an 8-hour exam with 8 of those hours being you physically being at boxes and hooking up different cables and configuring stuff. And so you're busy the entire time configuring things. And they give you a whole list of things that you have to do in order to pass it. And from what I understand, it costs like $1,200 or $1,500 to take the test. So if you're going to lay out that kind of money, you better pass it. But that's the highest level one. The lower levels are much less expensive. I think a CCNA test that runs about $250 or $300. So. We're just about out of time. Is there any other questions that we have?
Peter, when you click the help, and I've not been into it deep, and that's embarrassing because most of you guys got most of this done. But those pieces of information you showed about the formulations and all that, is that information available to the packet tracer and on the website, or did you just simply pull up information about the Cisco?
For the routing protocols?
Yeah, the stuff that you're just showing. Was that?
I actually did a Google search for each of those and
Okay.
just found the ones that looked like it was good information. You kind of have to be wary of what you find on the internet, but that looked like pretty good information there. So that's why I posted them.
I appreciate that. Yeah, I'm normally too embarrassed. So I normally don't go too deep, like with packet trace. Go, there's a help, but normally I've never been one to use the help on an internal package if somebody else had a better explanation for it. So.
Now with Packet Tracer, they have Cisco itself. If you sign up with the Cisco Academy, they have a complete course, and you can get a CCNA using that course. I think it's for free even. But you obviously have to pass the test, but you can take that whole course and learn pretty much everything you need to know just with Packet Tracer in order to get a certification.
Okay. Thanks.
All right, well, if that's it, I will stop our recording and you all can
a quick reminder about your paper abstract due at the end of next week there. Okay, on the